Good morning, everyone. This is Charles Ely, and welcome to the 12th session on the COMNET Modeling Guidelines and Procedures. Today, we're going to cover um, the HVAC equipment curves, and we're also going to discuss miscellaneous energy uses and on-site generation. So let's move right into it. The first slide that I put together here summarizes the COMNET equipment curves. The first column shows the tables that present the coefficients. The second column lists the equation numbers that are used to define the part load or temperature dependent conditions. And the third column shows the type of equipment and the type of adjustments that's made to the efficiency or capacity of that equipment. Um, there's quite a lot of detail here, and what we've done to help us get through it is develop a spreadsheet. We call it an evaluation spreadsheet, and this spreadsheet will be posted to the website with today's presentation, so that you can review the spreadsheet along with the video of the presentation. So what I'm going to do now is move to this spreadsheet and demonstrate for you a little bit about how you can use it. So the spreadsheet is entitled COMNET Equipment Curves. It has four tabs. The first tab shows the various data. Now this is data that's taken from the tables. The table numbers and titles of the table are shown in columns A and B. Column G shows the source of the part load efficiency data, or temperature dependent efficiency data. Much of it is taken from DOE2, which published part load and temperature dependent adjustment curves. Such curves were never published with Energy Plus, so we had to go back to DOE2 to get something to use. A few of them come from the ECB compliance supplement, some from the PRM, and the ones that we had to develop ourselves, we've labeled the COMNET curves. These came from various sources, including California's ACM manual and other documents. The DOE2 keyword that's used is shown in column C, and the curve name from DOE2 is shown in column D. So the columns H, I, J show the various coefficients. When the coefficients are not used or zero, I've just grayed them out. The curve type is shown in column N. It could be a quadratic, a biquadratic, a cubic, so forth. And then there's other data that's used for graphing. So let's move on to the next tab called linear and quad and cubic. So these all of the curves which have this type, you can choose from this list box up here. So let's choose a fan curve with variable with a VSD, variable speed drive, and so this shows where it is. It passes through 1 at 1, so there's no adjustment when the fan's running full out. But then you can see how the part load ratio changes with the fan ratio. You can choose other types of equipment here. For instance, let's look at part load adjustment for a screw chiller. It's shown in this table, and you can choose any or all of the quads or the adjustment curves that depend on just one factor, like temperature or part load ratio. The next tab shows curves that are based on two inputs. For instance, entering wet bulb temperature to the coils and outside dry bulb, for instance. And you can choose the equipment here. What we're looking at now is a water-cooled screw chiller, and we're looking at the efficiency adjustment based on temperature. You can choose other types of equipment. For instance, if you want to look at a here's another scroll equipment. Let's look at a air-cooled reciprocating chiller, so forth. So you can view the curves here, and I think clearly it's a lot easier to make sense of these curves if you look at them in a graphic form as opposed to trying to stare at the coefficients and figure out what they mean. We have another tab for cooling towers. Here you can specify the tower range and the approach, and the performance of the tower will be shown in the graph to the right. So as I mentioned, the source for most of this data was were the DOE2 defaults. Dick Lord from Carrier has been doing some significant work for the 90.1 committee to improve these curves, and when his data is available to us, we will take a look at it and probably dump the DOE2 defaults and use his, because he's developed data that better represents the minimum equipment that's specified in 90.1 and in NACA. His curves right now, I believe, deal mostly with chillers, but they're going to be expanded to include direct expansion equipment as well. All right, well, let's move on to the next part of the presentation. There's a number of components of miscellaneous energy use that are addressed in COMNET. They're listed here as opposed to under the section under plug loads or elevators, because these miscellaneous energy uses can be modeled completely separate from the building itself. They don't interact in any way with the building. They don't create a load. They don't reduce heat from the space. So these include water heating, exterior lighting, swimming pools, other electricity use, and other gas use. You'll notice looking at swimming pools, there's an error in formatting in the document. So swimming pools should have been 6.9.3, but instead it had a different formatting tag, so it didn't get a number and was skipped over. All of the data is still available in the MGP, but it doesn't have its proper numbering. I hope you can work through that. So let's move on to water heating. Following the convention I set last week, I'm going to show you the building descriptors for water heating, and then the text in red next to each building descriptor will indicate the specification for the baseline building. So the first group of building descriptors are system name, peak water use, schedule of use, and system configuration. These are all neutral dependent, which means that the baseline building basically inherits the conditions of the rated building. There's no credit. Although it is possible for the modeler to make adjustments in either peak use or schedule if they have an energy efficiency measure that they can document that reduces demand or somehow shifts schedule. So that's left there. Water heaters themselves that's the equipment within the system configuration that provides the heat. The building descriptors are name, type and size, capacity, energy factor, or thermal efficiency, depending on the size of the water heater. Sometimes there will be a tank standby loss, and then there will be a part load efficiency curve. The type and size of water heaters is a neutral dependent for the baseline building. So if the rated building has electric water heaters, so does the baseline building. If the rated building has a gas or oil water heater, so does the baseline building. The one exception to this is a heat pump. If the rated building has a heat pump, then you get credit for that, in that the baseline building assumes an electric resistance capacity, electric resistance type. The capacity is auto-sized, and the efficiencies, either energy factor if it's a small water heater that's covered by NECA, or thermal efficiency if it's larger than that. Those data come from 90.1, so those would be assets that would be a credit towards, or well, they have to be a credit because you wouldn't be able to buy equipment that was in a new building, at least, that was less efficient than NECA. And then the part load efficiency curve, you use the default. There's some other building descriptors that go with water heating, having to do with the recirculation system and auxiliaries. For the recirculating system, the building descriptors are the name, the pumping power, the schedule, and the piping configuration. All of these are neutral. Most of these are neutral dependent, which means they're the same between the rated building and the baseline. Pumping power could be different if you have a premium efficiency motors or some kind of special design that reduces pumping head. The schedule would always be the same. The length and sizes of piping are the same, but the insulation would be determined from 90.1. For auxiliaries, the size of the auxiliary tank, external storage tank, is neutral dependent, but the heat loss is based on an R 12.5, which is specified in the standard. There's no solar thermal, and there's no combined heat and water in the baseline building. The baseline building may, in some cases, have heat recovery when this is required by section 6.5.6.2. There's a requirement there that requires heat recovery in a few cases. For exterior lighting, again, the baseline specifications are shown in red. The building descriptors are named, the lighting category, which would be something like parking lot lighting, pathway lighting, facade lighting, the area and length of the lighting application, the power of the lighting application, how it's controlled, and a schedule for the lighting application. The lighting category is neutral and dependent, so if you have parking lot lighting in your rated building, so does your baseline. The size or area or length of the exterior lighting application is also the same. That's neutral dependent. However, the power and the control are taken from 90.1. So you could have reduced power in your rated building, and get some credit for that. The schedule is also the same, neutral dependent, unless the rated building has some type of control that's not already required by 90.1, and the justification can be made for some type of adjustment in the schedule. One of the things we've done in COMNET is we've developed some default schedules for exterior lighting, which are not in the 90.1 or the 90.1 users manual. Okay, moving on to swimming pools. Most of if the rated building has a swimming pool, then so does the baseline building, and most of the characteristics of the swimming pool are going to be the same. In other words, they're neutral dependent. The volume, the surface area, the schedule for taking on and off the cover, the temperature that the pool is maintained at, and the schedule for the temperature are all neutral dependent. Um, if there is no cover on the rated building, the baseline might have one though, because of section 7452 of 90.1. Pumping and filtration, there's three building descriptors: the rate, the power, and the schedule. Um, and these are all neutral dependent. Pumping power, however, could be different between the rated building and the baseline building if the modeler is able to document the use of premium motors or low head filters or some other technique that's going to reduce the pumping head. The equipment for heating the pool is, unlike water heating, it's always assumed to be gas or oil if oil and gas are available on the site. And if oil or gas are not available on the site, the baseline building it uses a heat pump, a water-to-water heat pump, or some type of heat pump to heat the pool. The efficiency of the heater is specified by 90.1, and the pool has no, the baseline pool at least has no solar thermal. So if there is a solar system for heating the pool, this would be offered as a credit. And again, the baseline specifications I've shown here in red. Moving on to other electricity use, this would be any kind of electricity use that's used in or about the building that doesn't contribute to the heat load within the building. And basically there'd be some peak power and a schedule that modifies that peak power. Those would be the factors, and there's no credit for them because these are likely to be some type of process application, and really the same is true for gas. The power and schedule of miscellaneous gas use or miscellaneous electricity use is neutral dependent. There's no credit. The same values go into both the baseline building and the rated building. So let's move on to on-site power generation. There's three types of systems that are laid out in COMNET: PV systems, wind, and cogeneration or fuel cells, or what's becoming known as CHP, or combined heat and power. PV systems are not applicable to the baseline building, but we have identified some typical building descriptors for PV systems, including the number of modules in the string, the number of strings, the collector area, the slope, azimuth, PV mounting height, which could affect shading. Shading conditions for PV arrays are very important. So one technique for identifying shading, which is used in the California PV Calc program, is to identify objects by their azimuth, height, and distance that could provide shading, like a tree or a chimney or whatever the object is. And then there's data for the performance of the collectors, and these are the things listed here, the common features that are used to characterize collectors. The short circuit current, the open circuit voltage, the maximum power point voltage and current, short circuit temperature coefficient, open circuit temperature coefficient, and the normal operating cell temperature, or NOT. These characteristics are published by collector manufacturers and are used by most of the software applications that model PV. PV could be modeled completely separate from the main building simulation, and then just added to the or subtracted from, I guess, the electric power from the simulation. So this could involve a separate on the side out of the box type of calculation. Wind systems are treated the same way. We don't have a lot of detail here. There's only 5 building descriptors: the name, the output, the wind speed, the rated wind speed, cut-in wind speed, and part load performance. These building descriptors are defined in more detail in the manual. And like PV, wind systems are not applicable to the baseline building, so we have no text in red defining what the baseline building conditions are. And for cogeneration and fuel cells, again, they're not applicable to the baseline building. There's a number of ways to model these, and all 3 of these, PV systems, wind systems, and cogen or CHP fuel cells, could be modeled outside of the simulation and then added to the simulation results through a spreadsheet or some other form. Many simulation programs, though, are adding features to accommodate PV, wind, and cogen fuel cells and so forth. So these could be handled. Fuel cells and cogeneration are lumped together here because all of the fuel cells that are available today use natural gas, just as a cogeneration system does. They, instead of burning the gas, they reform the gas so that there's fewer there's the combustion products are gone, but there's still the carbon emissions from fuel cells. They're just like cogeneration in that regard. So that's why they're treated here together. The last thing I want to mention, throughout these building descriptors, there's one of the features is or characteristics is something we call units. Sometimes it's square feet, sometimes it's BTUs an hour, or whatever it is. But sometimes it's a data structure, and data structures are listed here. They're defined in section 6.11 of the COMNET MGP, and they include things that require more than one value to describe. Examples are schedules of holidays, defining the surface, the geometry of a surface or an opening or a shade, construction assemblies, materials, things like utility rates. All of these are defined as common data structures, and they are defined in section 6.11 of the MGP. So with that, I'll wrap it up, and we'll have plenty of time for questions.